So good morning, students. So we discussed about electric lines of force. Now my next important topic is about electric flux. Electric flux very important topic है क्या चीज़ है? Suppose there is electric lines of force moving to this side. जैसे स्टीम लाइंस होती थी क्लास 11th में, ऐसे ये इलेक्ट्रिक लाइंस ऑफ फोर्स है. If I am drawing this side, it means this side is positive and this side is negative, and electric lines from positive to negative. Now in this path, let us suppose there is some arbitrary surface is placed. Surface area element वहाँ रख दिया मैंने. Now the normal of this surface in this side. So electric flux is what is electric flux? Flux क्या होता है बच्चे? It is number of electric lines passing normally through a given surface. ये जो सरफेस मैंने ड्रॉ किया इसमें से कितनी लाइंस पास करेंगी नॉर्मली? वर्ड यूज किया था हमने. That is called electric flux, and mathematically it is the dot product of electric field into area element of this surface, or we can represent it by the phi, or phi is equal to E ds cos theta. Question is, what is theta? Always remember, theta is angle between normal of surface with electric field. It is the angle made by the angle between the normal of surface with electric field, that is called theta. Let us explain further, do the clarity of this concept. So electric flux is the number of electric lines of force passing normally through a surface. Once again, phi we written as E ds cos theta. So this was my surface. If I suppose this is the normal, this side is electric field, this angle is theta. It is again normal. Always remember. Normal means if I take the example that my electric field is along x-axis. But my surface is my given surface is lying in xy plane. If it is in xy plane, then its normal will be along which axis? Z axis. That is k cap. And now if I find flux is basically E dot ds, area of that surface. But if you solve, you get eds. Now one is k cap, another is I cap, so it will be I dot k. And you know that both are perpendicular, it will be cos 90, so flux will be 0. Flux will be 0. So remember this, phi equal to EDS, and we have discussed that in class 11th. Whenever you have dot product, this is CBSE question, whenever you have a dot product, E dot A instead of DS, now I'm writing with A, but whenever you have a dot product, that quantity is A. This is CBSE question, that is electric flux is scalar or vector. Write its unit also. Now there are cases. The first case is if theta is 0, then cos 0 is equal to 1. Then if theta is 90, then cos 90 is equal to 0. So this is the case when flux is maximum. This is the case when flux is minimum. This is the case when flux is minimum. Another type of numerical might be asked that if electric field is given by 6 I cap minus j plus 8 k cap, and the area vector is given by 60 I cap, find the flux. So simply it will be E vector dot, you will do the dot product, you know that I dot I1, j dot I0, k dot I0. So answer will be 16 to 6, 360 with unit. Next question that come in mind, what is the unit? Unit of electric flux. So it is basically E dot A. Electric field unit is Newton per Coulomb, area is meter square. So it is Newton per Coulomb meter square. But it is very lengthy. Instead of using this, okay, let us write this phi as not as Weber. WB, Weber. So this is the unit that we will use in solving the numerical Weber. So flux is the lines passing through given surface. To this flux, to study further about this flux, let us solve one more numerical, very simple one. That numerical, that let us suppose this is a cube. This cube is at a distance of A from this side. Got it? The electric field vector is given by x की power 3 I cap. Got it? Okay, we have to calculate the electric flux through this cube. This is the question, and it is given me that electric field along this side. कोई problem नहीं. Let us start solving this. The question is this electric field is along x-axis. It means I will consider only two surfaces. क्योंकि बाकियों के लिए सभी के लिए थीटा क्या हो जाएगा मेरा 90 और cos 90 क्या है बच्चे 0. For this surface the normal in this side, for this surface the normal in this side. My electric field varies as the distance changes from the origin. So first I will find the electric field at this point by putting x value equal to A. So my E1 will be equal to A ka cube. To calculate the electric field at this point, now my distance from the origin is A plus A is equal to 2A. So my E2 will be equal to 2A ka cube. When I find the flux at point 1, it will be E1 vector dot area vector. So it will be E1A opposite electric field in this side. So angle will be 180. So it will be minus A cube into, let us write A with A. Later on we'll put the value of area of that surface. Similarly, what will be phi 2? It will be E2A vector. Now electric field this normal same side, so it will be EA cos 0 1, so it will be plus A cube, sorry 2A cube, 2A cube into A. Clear? So what will be net flux? You will, since it is a vector quantity, simply add phi 1 plus phi 2, so it will be minus A cube A plus 8A cube A. If you solve, it comes out to be 7A cube A. You put the value of A is the area, that will be side ka square, so it will be 7A cube 5. So sometimes question might become like this, that calculate the electric flux through the surface by putting in this formula. Thank you.